Hi everyone, so today's lesson is going to be about slope of parallel and perpendicular lines. We've been working on this concept a lot recently, and so we're going to take a look back at some algebra. So let's look at these different equations I've given you. First, y equals negative 6x minus 2. You should be able to recognize, number one, that that is a linear equation. Why is it linear? Well, the highest exponent of your x value is a 1, which tells me that it is a linear function, and this happens to be in slope-intercept form. So these are all things that we've been reviewing, so slope-intercept form. And remember, in slope-intercept form, you can identify that slope very quickly. It's the m in the equation, so our slope here would be negative 6. Now, I said I didn't want you getting tied to slope-intercept form, that more frequently you're going to feel more, I want you to be more comfortable with point slope and standard form. So let's look at number 2, 7x minus 2y equals 3. So this one is in the form ax plus by equals c. Ax plus by equals c, which we call standard form, okay? Now, you obviously all felt comfortable putting standard form into slope-intercept form to find the slope. But remember, we derived how you can find the slope directly from standard form by doing negative a over b. All right, so in this case, it would be negative 7 all over negative 2, so my slope would be 7 over 2. I want you to be really careful, though, with standard form. When you're looking at it, it has to be in ax plus by equals c form. You can see in example 3, I flipped it around. So just be cognizant of that and maybe rewrite it for yourself. 5x plus 2y equals 2. So then my slope would be negative 5 over 2. All right. So identifying slope from the different equations is really important. Now I want you to try the next couple examples and we're going to go over those in class. All right, but in parallel and perpendicular lines and their slopes, okay? So we know that parallel lines have the same slope, and we know that perpendicular lines have negative reciprocal slopes. Negative reciprocal slopes. Now remember, we can also call that opposite reciprocal if you feel more comfortable with that, opposite reciprocal. But I'd like you to challenge yourself and think about what the product of the slope of parallel and perpendicular lines are. So if we have, I don't know, a parallel line, we say its slope is 2, then the opposite reciprocal, the perpendicular line slope, would be negative 1/2. Now, let's talk about their product. What would their product have to equal? Well, product means multiply. There's that mathy word, product. So if I multiply these two together, 2 times negative 1/2, what's going to happen? Well, these two simplify down to 1, and I'm left with negative 1. And that is actually going to be true for every case except one. Except one. So I'm going to ask you to put some thought into what the counterexample would be. Remember, a counterexample is one example where it doesn't work, right? Where it makes it untrue. So tonight what I want you to do is I want you to think about what example, so what parallel and perpendicular slopes would not give me a product of negative 1. All right, so let's just go through and make sure we understand this. So here I give you an equation, x, let's look at this example, x plus 4y equals 12. All right, that's in standard form. So let's get our slope. Our slope would be negative a over b. So negative 1 over 4. So a parallel slope then would be negative 1/4. And a perpendicular slope would be the opposite reciprocal. So reciprocal means to flip it and make it the opposite sign. So that would be a perpendicular slope would be a slope of 4. How do we use this? So when questions ask you about parallel and perpendicular lines, you really need to always focus on the slope. Always focus on the slope. So you might be asked to write an equation of a line using the most convenient form if the line is parallel to y equals negative 4x plus 8 and passes through the point 1, 3. So the first thing I like to do is I need to think of what's the minimum I need to write an equation of a line, because it's asking me to write an equation of a line. Now, in class, we've been talking about that the minimum you need is a point and a slope. That's our minimum, okay? I need that to write an equation of a line. So I'm going to actually borrow the slope from this parallel line because I want a line that's parallel to that. So I'm going to borrow the slope. And if it's parallel, I want the same one. So my slope's going to be -4. And then the point I have is 1, 3. It passes through 1, 3. Now, the reason I like saying that the minimum I need is a point and a slope is because then that tells me I'm going to use the point-slope equation. All right, so point-slope. Recall that our point-slope equation is y minus y1 equals m times x minus x1. All right, so now I just plug those values in. My slope is -4. My point is 1, 3. So y minus 3 equals parentheses x minus 1. Now, to be honest with you, that's perfectly fine. Leave it there. Leave it in point slope. It asks for the most convenient form. You don't have to put it in y equals mx plus b. You could, but you don't need to. So I'm done. Again, if the question's asking you about parallel and perpendicular lines, you really always should focus on the slope. All right, so let's look at another example. Write an equation of a line that's perpendicular to the line 7x minus 2y equals 3. Perpendicular to it. If it's perpendicular, that means I need the opposite reciprocal slope. So again, I have to borrow the slope. However, this guy, it's in standard form. So I'm going to use that nice -a over b to get the slope. So I'm going to do -7 over -2, which is 7 over 2. Now that's the slope of the line given. I need the perpendicular slope. So the perpendicular slope is going to be -2 over 7. I have my slope. What am I missing? I'm missing the point. Okay, I forgot to write it on here for you. So I want you guys to check this example and put that it's going through the point 5, -1. Okay, so I forgot to write it in my notes. All right, so I've got my point, I've got my slope, so most convenient form really would be point slope. All right, so go ahead and try it, and then press pause and put it into point slope, and then come back and check your answer. Okay, so you're back, and so hopefully you got y plus 1 equals -2 over 7 times x minus 5. All right, last thing I want to look at is how to distinguish or determine if two lines are parallel, perpendicular, or neither. Well, again, if it's talking about parallel, perpendicular lines, then we want to compare or look at the slopes. So when I want to determine whether they're parallel or perpendicular, I'm really just going to compare the slopes. So again, it does matter what form they're in. If you look at my first example here, I've got slope-intercept form, so I can see my slope just by looking at it is -3 over 4. And then I need to find the slope of this standard form equation, so I'm going to do -a over b, which would give me -3 over 4. Okay, so now look at that. -3 over 4 and -3 over 4, they are the same slopes, so the lines are parallel. All right, I want you to try this next example and bring it to class, and we will check it together. All right, have a great night.